Hi, welcome to Weather and Forecasting Module 10, and this is part 4 of our set, and we're going to begin actually talking about the cloud masses themselves. So this is the cumulus nimbus clouds that are going to formulate into a thunderstorm, and there are 3 different types of thunderstorm that we can talk about. The first one is air mass. Air mass is your ordinary, simple cumulus nimbus cloud that has become a thunderstorm. And a thunderstorm is defined as a cloud that has a clearly set up updraft and a clearly set up downdraft. So there is air moving vertically up and air moving vertically down. Multi-cell thunderstorms is a grouping or bunching of thunderstorm clouds together, and this can be done in kind of a circular or oval shape where there's a bunch of them all together in kind of a rounded formation, very unstructured. Or they can be structured in a line of air mass thunderstorms, and that line is called a squall line. So it's a whole bunch of them in one line. And the final one is where I have a rotational updraft and a rotational downdraft, and it's clearly defined and it's very, very severe, and those are supercell thunderstorms. And so these are my 3 types of thunderstorm cloud formations that I can get. Once again, there are stages to my thunderstorm formation. So the first stage is what I would think of as just the formulation of a cumulus nimbus cloud, so my vertical cloud. And so that is my updraft only cumulus stage for my air mass thunderstorm. If that updraft then begins to develop a downdraft so that I have a clearly defined air mass going up and a clearly defined amount of the air within the air mass going down, that is what we call mature stage, and that's when I would name it a thunderstorm. I would say you are a thunderstorm now that have hit mature stage. Finally, when the updraft gets shut off and I have only a downdraft occurring, which means I'm going to run out of energy because I'm no longer feeding my cloud system, that is when I get to my dissipating stage on my cloud. And so there's 3 stages to the development of my thunderstorm. There is cumulus stage, mature stage, dissipating stage. Which brings me to when I want to name a thunderstorm, I can give it its nice scientific name, and that is a mesoscale convective system. And that is the nice name that I like to give a cluster or grouping of multi-cell thunderstorms. So when I cluster them together and I have a few air masses all in a bunch, right, that's when I will call it a mesoscale convective system. Sometimes this mesoscale convective system can line up in a singular line. Now, we talked about this in a previous module, but now we're talking about it again. If I create a nice linear organized lineup of thunderstorm clouds, I call that a squall line. And we talked about and we said that the squall lines tend to develop on the dry line in the United States. And so we get a lot of squall lines right along our dry line system. And here's an example of a squall line where I have a lining up of thunderstorms in its set, right? Here's another example where I have my squall line and my point, the line itself is traveling in the direction that the arrows are pointing at, but it's showing you the different stages. So this guy up here is in mature stage, but at this point he was dissipated and rained out, right? This one is in its mature stage, and now it's in dissipating stage. This one's in development, so this is cumulus stage. This one is now dissipating, or in mature stage, and then finally dissipating. Same thing with D and E. F developed last, and so it's still going in. If I started down here and had another line, T equals 3, I would see F dissipate out here and G getting to mature stage and then finally dissipating. So I can see this kind of line all moving across this way on my image, but in a line. And the line is actually lined up from the oldest stage to the youngest stage, the ones that are just developing as they're moving across. Now, one of the things that develops when I have a thunderstorm is that I have a clearly defined downdraft, and that downdraft produces a gust front. So the air comes out of the cloud, hits the ground, and then moves off in a very high speed wind. And this is a gust front. One of the things that also occurs when I have a gust front is I will see a small bit of the cloud actually pull apart at the base, and this creates what we call a shelf cloud because it's attached to the cloud face. So it's attached to the cloud face, and I get a shelf cloud. Underneath where my shelf cloud is and where my gust front is occurring, I can get what's called a rolling cloud. And this can sometimes be cloud air mass, and this can just be air itself that's not visible because the water has not hit its saturation point, so it's not in a liquid or solid form. And so sometimes it's unseeable and it's just there, but it's actually a mass of air that's rotating. And this is a rolling cloud. Rolling clouds are scary. If I'm getting rolling clouds, that is a telltale of putting out there a tornado warning. I would say that there is a tornado warning because the chances of that going vertical are pretty much almost going to happen for sure. Here's an example of the squall line, and down here I can see my clearly defined downdraft, which is hitting the ground, and then gust fronting. So here's my gust front, right? As it comes through. And here's another image set that gives me a little bit. So this is my clearly defined downdraft hitting the ground and becoming a gust front. So that's that air gusting out. I can see that my shelf cloud has developed here, and it's attached to my standard cloud shape. And then I have a little rolling cloud that developed up under here. And so I have a little rotational cloud system that's rolling around between the cloud itself and the gust front. So you almost think of like your hand is the pencil, and there's a desk underneath, and there's a little pencil in between, and you're kind of rotating the pencil under your hand, so you're rolling it. And they're doing the same thing with the air mass, right? I'm rolling the air between my surface or my gust front, my air on there, and the cloud itself and the forward facing of the cloud. And just think, when you are out doing something and you're seeing a storm come in, one of the things you kind of wait for is the picking up or the shifting of the air, right? I wait for the air to shift and the wind to begin to pick up, and then I'll say, oh, it's time to go because now the rainstorm's really going to start, right? You're at the beach and you're like, I can see it, it's out there. We'll wait till the wind picks up. And then the wind picks up, so you're getting hit with the gust front, right? And then you're like, okay, let's pack it up. Let's get out of here. Let's, stay safe. That brings me into supercells and what we consider a severe thunderstorm. If we give a thunderstorm, and it could be any of the three on top, any of those three types of thunderstorm on top, if we give it the designation of being severe, it means that the wind is moving at more than 58 miles per hour. It also means that there is hailstone potential that could be as large as 1 inch, if not larger, in diameter, and I will spawn a tornado. If I do any of these things, any of them, I give it the designation severe. So I only just need to do one of them, and I will get that. Now, keep in mind the hail thing. Thunderstorms produce hail, but it's often very tiny. It's only when it's really big that I will call it a severe thunderstorm. And any air mass, multicell, or supercell can be a severe thunderstorm if any of those three things occur. Now, with that said, certain ones, specifically supercells, have a better chance of it occurring. So it's not a 100% guarantee, but it's like an 80% guarantee that it will become severe if it has the structure of a supercell. And that brings me into talking about what we're talking about with radar and supercells and rotations. So, radar. One of the things I'm looking for when I'm going to have some type of multicell or supercell storm is what's called the hook echo. And this means that because the air is rotating on the way up, so I have a rotational updraft and a rotational downdraft, and in the blue is my updraft, so you can see it's actually spinning up, and you can see that the downdraft is actually spinning down. And this means that it's incredibly organized. This is an organized system. And because it's rotating, it's not going to dissipate easily. It's going to stay kind of clumped together in its structure. So it's able to hold structure better than an air mass thunderstorm. And this allows for the system to be strengthened and cause certain things to occur. One of them is the updraft can hold those ice crystal longer. And that allows for the development of big hailstones, so that can create a very severe situation there. The downdraft means that I can pull it down pretty rapidly, which means that I will get gust fronts. The air that's pulling down can gust at higher speeds.